So a very warm welcome also from my side, ladies and gentlemen. I'm happy to have the honor to speak to you about food security. As the chairman kindly introduced me, I am from the Ecosystem Services and Management Program at IIASA, and today I am going to show you some of the work that we have been doing lately in this program. And I'm going to focus on one important element that some of the previous panelists have already touched upon, and this is uncertainty. So, according to the current FAO definition of food security exists when all people at all time have physical and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. Starting from that, let's have a look at the latest statistics. So what you can see is that there has been some progress into reducing the number of undernourished people in the world. However, even in the latest period, the 2010-2012, 870 million remain hungry, remain chronically undernourished, and most of these people are living in the developing regions. So this is clearly a challenge to us, and one reason that has been very much put forth in the debate about this situation has been food prices and food price volatility. So while I am not saying that this is not an important element of the debate and an important point of analysis, let me show you this graph also to say that while it is important to look at short-run dynamics and to understand and analyze this, we should also not forget about the long-run trends. And I'm just showing this to you to underline that there's also other factors that we need to take into account. And there's a lot of challenges that work in an interplay to confront us with the challenge to meet food security. So food security has to be met within the planetary boundaries that Carlos was already mentioning before. I've already talked about food prices and price volatility, but other drivers that play an important role, we've heard it before from other panelists: population growth and the associated growth in food demand, rapid transitions in diets towards containment of more animal protein, competition for land, as witnessed by the late bioenergy discussion. Also, it has been pointed out that the decline in investment in food systems research will probably not help to address these challenges. There's pressure on natural resources, most importantly, water. Migration, both international from rural to urban areas, is definitely connected to this challenge. And so is political and economic instability directly related to availability and access to food. And last but not least, we are living in an uncertain world also pertaining to climate change. So what we do need, and this is in the very sense of what we are doing at our institute, is we need an integrated systems approach to tackle all these challenges in a comprehensive and sustainable manner. And while we try to do this, of course, at our department as well, I cannot focus on all of them in the remaining few minutes that I have. So for today, I'm going to focus on climate change and uncertainty. So to give you a flavor of the uncertainty that surrounds climate change and the projections that we are facing and that we are using to build our plans upon, I have brought you these two sets of maps. On the left-hand side, the precipitation change, and on the right-hand side, the temperature change, based on two different general circulation models. So this already, if you compare the upper and the lower panels, you already see that there is quite a big difference as to the extent, but also the location where we expect the biggest changes in the future. On top of this, we also have different concentration pathways. We have different scenarios depending on the underlying assumptions about drivers and response options that we have. Here denoted by RCP, representative concentration pathway, and while the dotted lines in this graph represent the different outcomes for climate change impacts on corn yields for different general circulation models. The solid lines represent the different RCPs. So you see these span quite a big range, and the question arises, well, if the future is so uncertain, what do we do if we have to make plans now? So what you can of course do is you can find the optimal strategy by using models for each of those scenarios. However, while this is a very good way to outline the potential scope of outcomes, it does not guarantee that if you have a strategy that performs very well under one scenario, that it will also perform equally well or leave you best off if another scenario materializes. So what we want to do is we want to find a strategy that ensures food security no matter which scenario materializes. And we use our program's Global Biosphere Management Model, which is a global bottom-up partial equilibrium model of the agricultural, forestry, and bioenergy sector in order to look more closely into these issues and find such robust strategies across the climate scenarios. So to give you a flavor of the results that we are currently looking into, if you look at the first 4 bars, they represent welfare in 2050, and the first 4 bars are welfare in a world where we face relatively little climate change. So this is denoted by the RCP 2.6, and the very bright column in green on the left shows you the situation where we are in an RCP 2.6 world, and we also chose optimally all the activities for this world. However, if we would have locked ourselves into a system of activities that would have been optimal for any of the other paths, we would have ended up in either the second, third, or fourth column. So in the worst case, actually, I've marked this red on the right side, we would end up in a situation with substantial welfare decline if we had chosen activities which would have been optimal for a relatively benign climate change, but then a very heavy climate scenario in terms of RCP 8.5 would have materialized. So according to those results, we can also have a look at food prices in 2050, and for exactly the same case, also here, the red bar on the right side, we see that in this situation, where we prepared for a much less heavy climate change than we are actually facing, we are in a situation of undersupply, and we see a pretty high price hike. So the lessons that we have learned, and we have run a lot more scenarios than that, I just wanted to give you a little overview of what we're doing, is that actually there's no single adaptation policy that proved to be superior across all climate scenarios. So in fact what we've seen is that locking into a particular agricultural system that performs very well in one scenario can actually imply quite a big loss in a different climate scenario. So if we want to move to a more robust strategy in an uncertain world, what we found is that flexibility enhancing measures are definitely one ingredient of such a portfolio. With that I mean access to irrigation, seeds, fertilizers, market access, and so on. So on the one hand side, we can work on resolving uncertainty, but on the other hand, we can also plan robustly in order to achieve substantial savings, both to the extent that we can reduce these situations where we have over or under production in order to ensure food security, and also the accompanying environmental implications in terms of land use, for example. So with that, I'd like to close. Thank you very much.